Hi guys, and welcome to a new video on data mining the social media with Python. And today we are going to talk about using the Twitter streaming API. And the streaming API is one of the favorite ways of getting massive amount of data without exceeding the rate limits. We have already discussed how this API differs from the other REST APIs, in particular the search API, and how we might need to rethink the way our application interacts with a user. So before digging into the details, it's worth looking at the documentation of the streaming API to understand its peculiarities. So I advise you to check this link and read through the differences. It's worth the read. So also in this section we will implement a custom stream listener by extending the default stream listener class, which is offered by Tweepy. So in order to save a lot of time, I've already written the code, and I'll go through the code and put the video on pause, and if you want to follow along, just write this code, and I will scroll down later for the next part. So just pause the video and write this. And I'll scroll down for the rest of the code. Pause this and write the code, and I'll explain in a bit. Okay, I hope you have copied the code, and I'll try explaining it. So the core of the streaming logic is implemented in the custom listener class, which extends stream listener and overrides two methods, onData and onError. These are handlers that are triggered when data is coming through and an error is given by the API. The return type for both these methods is a Boolean true to continue the streaming and false to stop the execution. For this reason, it's important to return false only on fatal errors, so the application can continue downloading data. In this way, we can avoid killing the application if a temporary error occurs, such as a network hiccup on our side or an HTTP 503 error from Twitter, which means that the service is temporarily unavailable, but likely to be back shortly. The onError method, which is here, in particular will deal with explicit errors from Twitter. For a complete list of status codes from the Twitter API, you can check the documentation, which are these, and we are specifically looking for the 420. So our implementation of the onError method will stop execution only if there is error 420, meaning that we have been rate limited by the Twitter API. The more we exceed the rate limit, the more we need to wait before we can use the service again. Therefore, for this reason, it's better to stop downloading and investigating the problem. Every other error will simply be printed on the stderr interface. This is in general better than just using print, so we can redirect the error output to a specific file if needed. Even better, we could use the logging module to build a proper log handling mechanism, but this is beyond the scope of this lesson, so might take a look at it a little bit later. The onData method is called when data is coming through. This function simply stores the data as it is received in a .jsonl file. Each line of this file will then contain a single tweet in the JSON format. Once the data is written, we will return true to continue the execution. If anything goes wrong in this process, we will catch any exception, print a message on stderr, put the application to sleep for 5 seconds, and then continue the execution by returning true again. The short sleep in case of exception is simply to prevent an occasional network hiccup that causes the application to get stuck. And the custom listener class uses a helper to sanitize the query and use it for the file name. The format file name function in fact goes through the given string one character at a time and uses the convert valid function to convert invalid characters in underscores. And in this context, the valid characters are three symbols, dash, underscore, and dot, ASCII letters, and digits. So when we run the Twitter streaming Pi script, we have to provide arguments from the command line. These arguments, separated by a white space, will be the keywords used by the listener to download tweets. I just did I ran the script on the elections in Punjab in India, which is very, very hot right now. The results are coming tomorrow. Today is 10th of March. 11th of March is the results are coming. So I ran this script for about an hour, and it created a file which was almost 13 megabytes, and it created a file with almost 4,101 tweets. There are some empty ones. I think it's approximately 2,000 because every second line is empty for some reason. And I used 3 arguments. The first hashtag. You have to use backslash to escape the hashtag because it uses hashtag to represent the beginning of a comment in command prompt. So use backslash to escape do the escaping of hashtags in the command line prompt. And so these are 2 hashtags that I used and a search keyword. So it created quite a big file with lots of information. Let's see how this looks. And it gives us the structured pretty big tweet. Lots of information. So, and there is another example that somebody used this code on. And in that example, he ran a script to capture the tweets about the final match of the 2015 Rugby World Cup played between New Zealand and Australia. And the fans following the event on Twitter were mostly using the hashtag RWC2015 used throughout the competition, and RWCF final used to follow the conversation about the final day hashtags. It's in the same way that I used here to follow the elections. So he used the two hashtags together with the term rugby as a search keyword for stream listener. And as I said, the backslashes before the hash symbols are needed to escape this character because the shell uses the hash to represent the beginning of a comment. And escaping the character ensures that the string is passed correctly to the script. So back to the rugby example, the kickoff of the event was set for 4 p.m. Greenwich Mean Time on the 31st of October 2015. So when he ran the script for 3 hours between 3 p.m. and 6 p.m. and produced nearly 800 megabytes of data with more than 200,000 tweets in total. So the buzz on Twitter did continue for a while after the event, but the amount of data collected during this time frame is enough to perform some interesting analysis. So when you come to analyze this data a little bit later, we'll get into this example, but also other examples that we have collected data from. So I hope you go and try the streaming app that you have written now, and with whatever hashtags and search keywords you would like to test it on. Pretty fun. So that's it for this part. And in the next, we are going to analyze tweets, entity analysis. So it's going to be a little bit fun there as well. So if you enjoyed the video, please hit the like button and subscribe to my channel. And I hope to see you in the next video. Bye for now.